Okay, this video is going to cover section 1.9 in our pre-calc book, and you might remember the distance and the midpoint formulas, and we'll also talk about circles. And we'll cover these objectives, find the distance between 2 points. We'll find the midpoint of a line segment, write the standard form of a circle's equation, give the center and radius of a circle whose standard equation is given, and convert the general form of a circle's equation into standard form. All right, let's start out here with the distance formula, and you've probably seen this before in another math class. The distance d between these points, x1, y1, and x2, y2, in the rectangular coordinate system is given by the distance is the square root of the quantity, the x coordinate subtracted, that quantity squared, plus the y coordinate subtracted, that quantity squared. We add them up and then take that big square root. So to compute the distance between 2 points, find the square of the difference of the x-coordinates plus the square of the difference between the y-coordinates. The principal square root of that is the distance. And this all comes from the Pythagorean theorem. If I put a point here, this would be maybe the x1, y1 point. And I could put another point anywhere else, and this would be the old x2, y2 point. So if I connect those and I want to find the distance between those, I could always drop this down to the x-axis and straight across from the y-axis, and I've created a right triangle. And remember, old Pythagoras said that a squared plus b squared is equal to c squared. The hypotenuse here is what we're finding with the distance formula, so that will be our c. And let's see here, if we call this side a, how long is side a? Well, we subtract the x-coordinates, x2 minus x1. And then we could call this side b. How long is side b? Well, that is the distance between the y-coordinates, y2 minus y1. So that's side a and b, and if we put it into the Pythagorean theorem and square them, here is our a squared plus b squared is equal to, this over here would be c squared. And then to solve for c, we would take the square root. So there is no longer an exponent here above this variable, and now we add the big old square root over the whole thing. So the distance formula just comes from the Pythagorean theorem, and they put that in the coordinate plane. Example 1. Find the distance between these points. Now, I'm going to put a big old radical here, and I'm going to subtract my x's and square it, and I'm going to add to that my subtraction of my y values and square it. So here I got this all set up, and I've just left everything blank where the numbers go, and I'm going to put them in there left to right. So I'm going to put in the -1 and then the 3. That's a -1 minus 3. And then 4 minus -2. 4 and then minus a -2. If you reverse one or both of those, you're still going to get the right answer, because we're going to subtract and then we're going to square. The square will make sure everything's positive. So let's see here. -1 minus 3 more is -4, and that's going to be squared. And then here, 4 minus a -2, we add the opposite, so that becomes a 6 squared. So under our radical, we have a 16 plus a 36. That adds up to square root 52. Now, it's hard to see, but there is a perfect square hidden in there. 52 we could rewrite as 4 times 13. The square root of 4 we can bring out. Square root of 4 will come out as its root 2. So 2 root 13 is that distance. Ooh, and I just noticed here it says simplified in radical form and then also rounded to 2 decimal places. Now, luckily I have my T89 right next to me, so I'm punching in 2 times the square root of 13, and give me a decimal. That is 7.21. So for the decimal part, 7.21. Now, I did put a graph in your notes, and let's just see here, if we can get an idea what this looks like if we graph it. -1, 4, our point would be up here. And then 3, -2, we're down here. So what we found was this distance. And again, if I take it to a right triangle, I can always connect these sides at a right angle here. And we found this side, that was our 4 that we squared. And then this side here was our 6. So a squared plus b squared equals c squared. We would add that square and this square, and then take the square root to find our hypotenuse squared. And here's the better looking book graph. So the distance between that is 2 root 13. Not example 2, the midpoint formula. Well, let's just read what the book has. Consider a line segment with these endpoints, x1, y1, x2, y2. The coordinates of the midpoint of that segment is, we add the x's, divide by 2, comma, add the y's, divide by 2. We're finding the average here. The average of the endpoints will be the midpoint, so adding the x's and dividing by 2 just makes perfect sense. And what's this great question? Do I add or subtract when applying the midpoint and distance formula? Easy to get these confused. I see it every year. In the midpoint, you are finding an average, so you add and divide by 2. Here we're finding the length of a side, so we are subtracting, and then we're going to square it at some point. Okay, example 2, midpoint formula. So again, our answer is going to be a point. So there's my comma. And we're going to find the average. So here we're going to add the x's and divide by 2. And then the next one we're going to add the y's and divide by 2. So my x values are 1 and negative 8, 1 plus a negative 8. And my y values are negative 6 and negative 4. So if I add this numerator, 1 minus 8 is negative 7 over 2. Comma, negative 6 plus negative 4 is negative 10. Cut that in half and it's negative 5. If you're not a fan of fractions, you could turn that into a decimal. Negative 3.5, comma, negative 5. Now it doesn't tell us to graph it, but if we made a mistake, we could catch it with a graph. So let's graph our endpoints here. 1, negative 6, right about here. Negative 8, negative 4 is right here. And if I connect the dots, whoa, that's pretty terrible. Well, I'm not going to waste the time getting out the line tool. Close enough. Now let's graph this point and see if we're on that line. Negative 3 and a half would take me to about here, and then down 5. Ooh, my line is pretty far off. Let me get over that. I am going to bring out that line tool. There we go. Let me get rid of this. So if I connect my endpoints, aha, now it looks a little better. Our found midpoint was negative 3.5, negative 5. Well, here I am at negative 3.5. Now if I go straight down, it does look like, oop, get out of there. We are hitting right there at about, ooh, hold on, that's a little off. Oh, that's it. I messed up one of my points. It's 1, negative 6 over 1 down to negative 6. So that blue dashed line should be coming over to here. Now, if we go down from negative 3.5, we hit the graph. There we are at 5. So just a little malfunction there, but we've powered our way through. And here's the book's graph on that. There's the end points, and the midpoint should fall on the segment. And here we can eyeball. It does look like it's halfway there. Now circles. Our goal is to translate a circle's geometric definition into a algebraic equation. First, let's reminisce here on a definition of a circle. So a circle is the set of all points in a plane that are equidistant from a fixed point called the center. The fixed distance from the circle's center to any point on the circle is called the radius. So, and I'm not going to read through that text, but let's just look at this picture. Here's a point on the circle. X comma y is how we designate any point. The center of a circle is so special it gets its own designation letters, H and K. H is the X value, K is the Y value of the center of the circle. So let's find the length of this radius. We can use our distance formula. So the distance formula, or here the radius, is going to be the difference in the x coordinate squared plus the difference in the y coordinate squared under a big old radical. So if we take this and we square both sides, that will give us the standard form of the equation of a circle. So again, we square both sides. Now we have r squared, our radius, is equal to this. Now the radical is gone. X minus h quantity squared plus y minus k quantity squared. The center, hk, is right here. The center of the circle is kind of looking right at us from inside those parentheses. Alrighty. So this last example, we're going to do a lot more with circles and stuff in the next video, in the next lesson. For now, we're going to stick to a very basic circle that is centered at the origin 0, 0. So write the standard form of the equation of a circle centered at 0, 0 with a radius 2, and then we're going to graph it. So first, because the equation's new here, let me just copy it. X minus h quantity squared plus y minus k quantity squared is equal to the radius squared. Now again, the h and the k are the center of the circle. Here is the given h and k. Our circle is centered at 0, 0. So this is going to be x minus 0 quantity squared plus y minus, our k value is also 0 squared, equals r squared. Now that's technically correct. Everything's in the proper form, but we can make it look a little prettier. Let's work on our grouping symbols. X minus 0 is just x, and we can just square that. Plus y minus 0 is just y, and we'll square that, is equal to r squared. Okay, now my favorite part, graph it. So the first thing I do is plot the center point of the circle. Here it's going to be 0, 0, and we know the radius on this one is 2. So we can go up and down 2, we can go left and right 2 from the center, and then we can connect the dots in a somewhat circular shape. Close enough. Here's the book's graph. So centered at the origin, radius of 1. Ooh, now I do believe on maybe one of the worksheets, they might go a little farther and ask about the domain and the range based on the graph. So if you're asked to find the domain and the range of this, remember the domain axis is the x-axis. So the circle is defined from x equals -2 to x is +2. The range is defined by the y-axis. So here our circle goes from -2 to +2 also. So the domain and the range we can just get by looking at the graph. Here are 3 checkpoint questions, 3 practice problems for you so you know the routine. Pause the video and then try the problems out. Fire the video back up and compare your answers with mine. All right, the first one, distance between the points. So I got a big old radical. And then I'm going to do my first x value minus my second x value and square it, plus my first y value minus my second y value, square that. And let me get myself a little more room here. -1 minus 2 more is -3, and we square that and get a 9. Plus -3 minus 3 more is -6, square that and get 36. Add those up and you get the root of 45. Now 9 is a perfect square hidden in 45. 9 times 5 is 45. We can root the 9 and bring it out as a 3. 3 roots of 5. Number 2, midpoint of this line segment. Oh, now here, I should have done this in the example. I did midpoints another way when I was in high school. A different way to do this is you can line up your points in columns. Ooh, that's a terrible 3. There's a little better. Now what we're going to do is add those together and get this point, and then we're going to divide by 2. So if I add my x's, I get 8. If I add my y's, I get -1. And now we're going to divide by 2. So my final answer for the midpoint is 4, -1/2. Number 3, equation of a circle centered at the origin, radius 4. So if you went through the full song and dance, x minus 0 quantity squared plus y minus 0's quantity squared is equal to 4 squared. So that becomes x squared plus y squared is equal to 16. Now, the problems in the book were not hard enough, in my opinion, so I found a few extra problems out of a different book. So these are just some more practice problems. Here are 15 and 17. This we're finding the distance between, and we got mixed numbers here, a number and a radical. So be extra careful there. And then we're going to check those answers, and then we're going to do the midpoint of fractions and also some mixed with radicals here. So again, pause the video and start working on these, and then check your answers by starting the video back up. Oops. Okay, distance formula. I'm going to do a big old radical, and then I'm going to start by subtracting my x's. I got a 3 root 3 minus a negative 1 root 3. And that quantity will be squared. And then I'm going to do the same to my y values. My first y value is a 1 root 5 minus a 4 root 5 for the second y value, and that will be squared. Okay, here we will add the opposite. And what do we have here? We have 3 roots of 3 and 1 more root of 3, so we now have 4 roots of 3, and that is still a squared quantity, plus 1 root of 5 minus 4 roots of 5 is negative 3 roots of 5. We're just considering the radical as an x. Like here, 3x plus 1x would be 4x, but the x's are now roots of 3. Okay, if you're going to make a mistake, usually here is where it's going to occur. You know, we're squaring a number that has a whole number part and a radical part. So what we're going to do here, if I just come down here for some scratch work, 4 root 3 squared is 4 times the root of 3 times another 4 times another root of 3. So we square the 4's and we'll get a 16, and we will multiply root 3 times itself, being the root of 9, or just 3. So don't lose track of the radical. We're going to switch to a different ink. We're going to square the 4. 4 squared is 16 times square the radical. Root 3 times root 3 is root 9, or just 3, plus square the negative 3. Negative 3 squared is positive 9, and we're going to multiply that by the root of 5 times itself. Root 5 times root 5 is root 25, or just 5. Okay, I'm just going to work my way back up here. 16 times 3 is 48, plus 9 times 5 is 45. If you add those up, you get 93, root 93. And I'd just say leave the answer as a radical. We don't need any decimals here. Okay, next one. Let me get that out of there. I believe we had some fractions. There it is. Okay, again, the distance formula, we have a big old radical. And then we're subtracting our x's. So my first x is 7/3 minus my next x, which is 1/3. That will be squared. Plus y values. First y value is 1/5 minus the next one is 6/5, also squared. So 7/3 minus 1/3 is 6/3. And then 6/3 will reduce down to 2, and 2 squared is 4. Plus 1/5 minus 6/5 is negative 5/5. Negative 5/5 is just 1. Negative 1 squared is 1. So we got a radical. Under the radical is a 5. 4 plus 1 is 5. So there is a distance formula with a fraction, and then also with the mixed numbers with radicals. We're going to do the same thing now for a midpoint. So pause the video, find these midpoints, and then check your answers. So let's see here. First, we're going to add the x's. My first x is negative 7/2, plus my next is negative 5/2. y values. 3/2 is my first y value, plus a negative 11/2. Now this looks scary, but watch how this problem develops very nicely. Here we have our numerators -7 and -5. That will be a -12/2. And that's still over the big blue 2, comma. Here we have, get out of there. Here we have 3 minus 11, that is -8. Still over 2, and then we have our big blue denominator 2. So this, divide that, you get a -6. -6 over 2 is -3. Divide this, you get a -4. Half of -4 is -2. So the endpoints are all nasty fractions here, but the midpoint lands right on a nice sweet spot, right where the graph paper grid intersects. And let's see what happens here. So the x-coordinates won't be bad. Our x-coordinates are just nice whole numbers. So that's going to be get out of there, 8 plus a -6, and we're going to divide that by 2. And then for the y-coordinates, we have 3 roots of 5 and a 7 root 5. 3 root 5 plus 7 root 5 over 2. So here, 8 minus 6 is 2. 2 divided by 2 is 1. And we got a comma. If we add the numbers in front, 3 plus 7 is 10. So that is 10 roots of 5 over 2. Divide the 10 by 2 and you get, root 5. 10 root 5 divided by 2 is 5 root 5. There we go. So there's our midpoint. The homework for this section is a worksheet where I crossed out work because we don't work in math class. We have fun. We do fun sheets in math class.